Oh, wonderful. Can everybody hear me okay? Hello?
A chair of yes.
Yep, yep,
It's
yep.
not that I'm new
Okay.
to this. Right, so we've got 105 slides to do. So let's get cracking. Everyone's watch the numbers dive. My name is Rob Miles. Let's see if I can, there we go. Quick overview. I'm going to show you some code. I'm going to show you some stuff. I'm going to go real quick, but that's okay because all the slides and whatnot will be on my world famous blog, which is robmiles.com. I'm sure you all go there, but if you don't, then please do. So a bit about me, bit about stuff to measure, bit about Azure IoT Hub, bit about a thing called LoRa, and then a bit about spider eggs. And then we all go home for tea. Well, I've had tea by now, but that's another story. So, okay, I spent 38 years at University of Hull, twisting minds and crushing dreams. I left that a few years ago. I'm now an MVP. I've been an MVP for quite a long time too. I blog at robmiles.com. I tweet at robmiles, and I write books. This is one of my books. Look at that, one customer review, 5 stars. Thanks so much, Mum. More recent book, more of the family involved in this one, but a slightly different range of possible responses there, which I can live with. I'm presently working on the 3rd volume. It's becoming a trilogy. I'm doing a book about JavaScript, which is fun. I like all my languages. I like C#, I like Python, and I'm starting to like JavaScript. If you want to hear the chapters being read out, and who doesn't, then I'm reading them out on robmiles.com/jspodcast. So please listen to that and tell me what a fool I'm being. I'm up to chapter 2 or 3 now. Yeah, it's just getting the interesting bits. Yeah, fun is starting to happen.
When you say starting to like JavaScript, how long did that take?
When I found out more about it, because everybody was telling me, oh, don't go near it, it's horrible. But they said that about Python, and that was wrong as well. So yeah, I do think it's quite cute. It's scary, and from a teaching perspective, it's fun. But have a look at my stuff on the podcast page and let me know what you think. That's kind of like a loaded question too, because I'm not quite sure which way to jump on it. But yeah, all languages are great and all languages are horrible. And you can write great code in a language and you can write crap code in a language. And that's basically it, folks. But it all pays the mortgage, which is good. I'm going to move on to the next slide because I'm going quickly. Why do we want to make one of these things? Why do we want an air quality sensor? How does it change your life? Well, someone was saying before I did this talk, it's now quite a hot topic because it turns out that breathing bad air is bad for you. And you want to be able to measure the air to find out if it's good or bad. Now, the Met Office already do this. They have stations around the country and they measure stuff and they feed it into a big computer model, and we know how good they are, and they tell us what kind of air quality we have in our region. And they're kind of okay, and they're generally all right, but I'd like to kind of know, because everything which is calculated comes from different models and whatnot, and I want to know what it's really like. And so we thought, as an exercise, we'd build some sensors, see what the numbers look like, and see where we go. And this has turned out to be very interesting. It's like climbing a sequence of mountains. You get to the top of one mountain, you find a great big one behind it, which you also have to climb. It isn't a technical problem, it turns out. But that's a bit further down. That's giving the ending away. That's a bit too much detail there. Let's keep going. This is, if you look on the scales, this is what air quality looks like in terms of how numbers stack up from the AQI, the air quality index. 0 to 50 is good, above 201 is not good. And this is covering lots of different things, including nitrogen dioxide and other kinds of NO, which is not good. We thought we'd start with this stuff because the sensors you can get for this are fairly easy. And this is PM 2.5. These are tiny 2.5 micron particles. And we thought we'd have a look at these and move on to NO and other things when the tech catches up, because the tech's quite expensive and hard to manage for this. So there we go. This is I did not draw this diagram. I stole it off the interwebs. The human hair is that big. Beach sand is that big. The things we're looking at, if I can move my mouse, all kinds of things will happen, is this stuff here, which is tiny, tiny, tiny. and it's 2.5 microns, where a micron is a millionth of a meter. So these things are very, very small. They come from smoke, basically. That's one of the major places we get these things, from fossil fuels and vehicles and all that kind of stuff. And what I was trying to do as we started this is try and convince people that you can change how they behave with tech. If you make people aware of the effect of what they're doing, then perhaps they'll do something different. Plastic bags and doggy poo are a good example here. It is now not acceptable to have your dog do things on the pavement and you to walk away from it, because society says, no, you'll pick that up and carry it home, which must be lovely. And so we do that. And if we can get people looking at numbers outside schools and seeing them going up in certain situations and going down, if they go down in the school holidays and up when school's on, then maybe that means there's something being caused by people turning up in their Chelsea tractors to drop their kids off. So the idea is to try and get people to think in terms of, I'm going to change the way I do things because I am now better informed. And I'm quite keen on that. And I'm kind of hoping that one day it might actually work. And the other thing which I like as well is that if you're going to try and learn about a particular tech, you can watch lots of YouTube videos and you can sort of think you know stuff. But it's not till you really build something you find out all the real horrible problems. And so if you want to learn a technology, you want to learn about networking, IoT devices, how to manage them, deploy them, what the issues are. And we wanted to do that. So we thought, let's build something, let's build air quality. We thought the hard part would be getting the sensors to work. That's not true. The hard part is not getting the sensors to work. The hard part is convincing someone to let you plug something into their mains, because, or worse yet, use their network, because they just don't like that. They're very keen to help, and you say, we need mains, and they go, oh, can't have mains, sorry, and then you move on. But yeah, okay, so it's kind of like, I like building stuff and seeing what happens, and this was a great place to do that. And so we all got together and started measuring air quality. So a bit of tech about how you actually do it now. This is the air quality sensor type that we're using. We have, this one uses a resistor, which is the thing. Can you see my mouse moving? Can we? Gone quiet. I'm the only person here. Everyone else left. There were 38 when I started, including me. And so we'll see. This is a resistor heating things up at the bottom. The air rises up. We have an infrared LED shining light through the rising air. And then we have a photodiode looking for twinkles. And if you see a twinkle, that means basically a speck of dust has gone past. And on the back of this board is a great big microcontroller, which is actually taking the signals from this thing and doing all kinds of wonderful things to figure out whether there are microparticles there or not. And you can go onto AliExpress and you can buy one of these for $5, which is completely and utterly insane. I don't know how they do that, but they do, and they work. And we've shown them, we've seen them working. And so I have confidence. This is my preferred weapon. This is the Nova PM SDS 011, which is a bit more money, 13, 14 quid. This guy has a fan, that's the black bit on the top, that pumps the air through, and you can stick a pipe on the inlet. So you can actually run pipes out to the outside, bring the stuff in and do things with it. This bit down here is a board that plugs it into the USB on a PC. So you can use it on a PC or in an embedded device. And you can buy one of these guys and you can fire it up and it will give you a number which comes out, which is how many twinkles it's seen in the last however many seconds. And then it just keeps on spewing these out. And you get your numbers and hey, you're measuring something. You're measuring particles, which may or may not be air quality. And so once you've got your thing, you then think, I need a microcontroller because that thing just gives me numbers. I want to put it onto the interwebs or somewhere. So now we get into making our own embedded devices. And these things are awesome fun. Making embedded stuff is fantastic. And now you can do it in Python and JavaScript, and as well as C++. And you should all be doing this because it's just amazing. The Arduino platform is a good one to use. That's C++. And this is a fantastic chip, the ESP8266. You can pick these up for about £2.50 a pop. That's less than the price of beer. I haven't bought any beer for a long time. But this stuff, you can get proper code running on this. You can do secure sockets, UDP. It's got Wi-Fi built in. It'll work as an access point. You can make it into a web server, for heaven's sake. And you can also plug it into a sensor and use that to actually push numbers onto the network and start to track them. So it's just Yeah, okay, that's a good one. This is even, we use these two. This is the ESP32. This one is even more powerful. This one has Bluetooth. It's a dual core device with 16 mega RAM, and it goes, and it's a $5. It's just crackers. These guys you can write. Say again?
I've not played with it yet. I ordered a couple, one with a built-in OLED, and just to play one.
That's the Heltec one's quite a good one. That's the one we're using in our lamppost sensors, of which more in a minute or two.
Okay.
That one costs around 15 quid, which is fair enough. That one gives you LoRa, of which more a bit later as well.
Oh,
LoRa
yeah, I've got one of those. I haven't played with that yet, but apparently it'll do 12 kilometers according to that Swiss guy on the internet.
On a good day with a flowing wind and nothing in the way, you might be right.
From two high points with a line of sight.
Yeah, you can. Over the summer last year, they had some really wacky ranges, getting things from Holland and all sorts because of the way that the inversions in the air propagated the signal and whatnot. But this is a nice device to play with and very, very cheap. If you want low power, I can recommend the Fire Beetle. This guy can take you down to less than one of a milliamp in deep sleep mode, and that will also control a lithium-ion battery. And that's kind of cute. I'll put references to these on the world famous blog, and these are quite nice.
Have you heard of the satellite, the LoRa satellite they got launched, sort of Pico satellite?
Oh yeah. I've not done much with it. They were going to have tiny bursts of signal. I mean, I'll talk about LoRa a bit later, but I don't quite see how it's going to work, but it is very interesting. This is a shameless plug from my article in this month's Hackspace magazine, where I'm using a real-time clock to control a microcontroller. In this case, it's actually a Pi Zero using a MOSFET. So rush out and buy that, or if you're too cheap to do that, go down to that web link and actually read the whole thing. It's a good read. And so you can use real-time clock chips and whatnot, and you can program these things. I like C++. You can use Visual Studio Code to make the stuff and deploy it. And there's all kinds of pre-built libraries. If you fancy writing that kind of thing, you can make appliances. I've made some stuff called the Monitair sensor node firmware that sounds great. Because it's an ESP8266 I'm using, I can make it into an access point, which I can connect to from my phone. I then have a web page I use to configure it. I then have a command line sort of a setup where I can just basically whack things in and hit update, and it then puts these things inside the device and configures it. So you can make it, configuring it is easy, and making these things is kind of fun as well. And I can talk to it over the serial port to tell it what to do also. And all this stuff is up on GitHub if you fancy having a play and making some sensors of your own. But we've had quite a lot of fun making this and getting it to go. This is another one you should be aware of called the M5 Stack. These things are super nice. They're dirt cheap, they're beautifully packaged, and they have a web-based programming environment which you can deploy to over Wi-Fi, and you can write Blockly, which is fun, or you can write Python, which is proper. And that's a very nice place to work. If you've got kids, that's a good one to go with them as well, because it's kind of immediate, and they've got some robots and some tracked vehicles and things you can connect as well. And the prices are pretty close to pocket money. So go and have a look at m5stack.com, because that's a nice place to start making your bits and pieces as well. All kinds of fun to be had with that. This is my first sensor. This is what I call the flower box, because it's got a flower on it and it's a box. And there's my breadboard prototype. There's my sensor, and there's one in a 3D printed box with a flower on it. And that will give me stuff. I can put a GPS receiver in it too, which is this thing here, so I can geotag my readings. And I can go off around the place, and this thing will push values into MQTT over a serial port, or use LoRa. And it's very easy to put an SD card in there and log things to a card, which you then bring back and plug into devices. There's all kinds of fun you can have with this, all kinds of good things you can do. I'm going to talk about how many folk here, quick show of hands, this doesn't work at all well. I'm using a thing called MQTT. Are folk familiar with MQTT? The chap before me from IBM should know this because IBM invented it. It's basically a way of sending packets of data around the network. It's a really nice way to hook things together. It stands for Message Queue Telemetry Transport, which is quite a mouthful, but it's a really cheap way, an easy way to push data around the network from low-cost sensors into Raspberry Pis or servers and beyond. And I like it quite a lot. It basically thinks in terms of endpoints and subscribers and publishers. So you can subscribe to an endpoint and then anyone that publishes to it, you get that message. And you can have as many publishers and subscribers as you like. We have a topic which is air quality, and we have all our devices publishing to that, and then we just harvest all those, pull out the IDs, and whack them in our database. The ESP8266 will do that, as well as most of the other small devices, and the Azure IoT Hub works as an endpoint. And it's a great way. Start playing with this. You don't care what the packet's got in them, that's down to your application. You just push chunks of data down up to about 2 or 3K. Will work all right with that. And in terms of what you have a thing in the middle called the broker, who sits in the cloud or wherever you like, or at home on your Pi. Your sensor node publishes to an address, your data connectors subscribe to that address, and then stuff just gets pushed backwards and forwards. I'm sending chunks of JSON because that's kind of easy to do and universal and works very well. And I use a thing called PubSub Client, which is another free library for Arduino you can use to send and receive these MQTT messages, and it works a treat. Microsoft have a client you can use as well, but I like PubSub Client because I've actually used it and it works. Yeah, I've got that. So in terms of what your C# program has to do, we basically grab ourselves a server with, this is the address on the interwebs, this is the port number you're using, there are well-known port numbers for this. Set a method to be called if a message arrives from the broker, and then just connect. And you give it the device name, the username, and the password. And at that point, you're away. This is not particularly secure as is, because these things, username and password, are sent open text over the wire. But there is a variant of this which uses secure HTTPS effectively, so you can actually have the thing encrypted, which is nice. So keep that in mind. But for around the house on your private network, this is absolutely fine. I then publish to a particular topic, air quality / data, a buffer full of stuff. And if I want to, I can listen to a given device, or all the things on the data topic, all the things on air quality. So I can use wildcards and that kind of stuff. And MQTT, you can buy thick books on it if you like, but that's pretty much all you need to know. If I want to, I can subscribe to a topic, so that when somebody else publishes on that topic, my code in my endpoint will get fired off. So if you're going to turn lights on remotely, MQTT will do that for you as well. I've got some robots I can send messages to make them actually respond and do stuff on the back of receiving an MQTT message. So this is all good stuff. In terms of how it works in Arduino land, you call a loop a heartbeat function. You can see my hands. To keep going round, to actually go around the robin and sort things out and do that, all that kind of stuff. And that's how it all keeps going. There's different levels of quality of service. There's fire and forget, which is level 0. And there's one in the middle where it's guaranteed to get at least one of them. And quality of service 2 is it'll arrive exactly once. And you have a thing called last wishes, where a station can say, if for some reason I drop dead, send this message. And then you can tell everybody that you've dropped it if they haven't already figured it out by the fact you've gone quiet for a week. So there you go. There's all kinds of fun you can have with this. We just use it to push data backwards and forwards. Here's some empty resources. This thing here, Node Red, another IBM product. I don't know why I'm plugging IBM, but there you go. Is another free tool which you can use to design flows of data through applications, including stuff that comes in from MQTT. This guy's a very good broker for Raspberry Pi, and the PAHO project has got versions of MQTT client software in a whole range of languages, from Python to C# to C++, to whatever you like. And that's worth looking at as well. So are we all okay? We've got the sensor sitting out on a lamppost somewhere, talking to a device that's hooked up to Wi-Fi, and it's pushing up MQTT messages. Let's have a go at looking at things from the Azure IoT Hub side. And so the Azure IoT Hub is a complete device management framework, and you can do simulation too, which is nice. So you can suddenly fire up 500 sensors and start them firing stuff. This stuff is proper. One of the things about IoT that worries me is you can make simple, dodgy systems really easily. What you want is a proper one you can deploy and stay sane, and that's what you get with IoT Hub. And there's a really nice free tier. If you want to have a go with this and get your feet wet but not actually end up spending any money, then a certain number of messages a month, if you say below that, it's free. So you can fire this up, you can spin up an Azure IoT hub and start passing things around, and it'll cost you nothing. And it works extremely well. We have the IoT hub in the middle here, which is taking my sensor nodes. It talks to the Azure service bus. And then at this end, you can put what you like there. You can put apps, you can put databases, you can put whatever you want. I've got an ASP app that I use to send robot programs backwards and forwards, but you can pipe that wherever you want. And there's all kinds of good stuff. This process here is a secure channel now, and you can actually put keys on there that will expire. So your devices out in the field can drop dead. Each device and people it'll find the device, get the key out, still can't use it. You can disable devices on device by device basis. A lot of power here. You've also got some very nice shadowing where you can have a virtual and a real one, and you can play with that. And this is all very good. I'll put a slide up because if you do decide to use IoT Hub, you find that all the names of things change in your PubSub client calls. And this is basically a mapping between what normal Mosquito type stuff likes, which is the MQTT that you use on simple devices, and what IoT Hub likes. So I'll leave that there for reference, and I'll talk about Device Explorer. Device Explorer is a program that you can run on your PC that lets you talk to your devices via IoT Hub. And what I did here was I sent one of my devices Hello World, which is kind of obligatory in these businesses. And it actually popped out the other end of my device. Didn't know what to do with it, but it knew it had received Hello World. So you can play around at a sort of management level and fiddle with these things, but there's also a big API you can use to make a workflow. So you can get your devices off production lines, stick barcodes on them or QR tags. You can then have a process that onboards them onto the IoT backend and gets them all done. And so you can build all that workflow as part of your solution, and you should. That's how you should do it properly. If you use Visual Studio Code, if you go down here, there's an IoT plugin which you can put in there. So now you can actually start playing around with your devices at a device level and configure and play with them inside code as a development aid. That's kind of cute too as well. That's kind of like a fun place to be. So what we've got now is we've got our systems getting particle values. We've got those going into an embedded device. It's talking MQTT, and we're going to an IoT hub. And this is going to be the bit where we use Azure functions to pick up the incoming MQTT messages and do things with them. So this is kind of like the next link in the chain. And Azure function, these things are fun. These things are really nice. You don't have to have a server anymore. You can whack a piece of C# up in the cloud, and when the event occurs, your code runs and then goes back to sleep. And I really like this. And so I've got a bit of code sitting in the cloud. It's triggered by IoT Hub, which is this thing here, but I can trigger it by HTTP requests, or just a time-based one, or an event hub inside Azure. And so I have a bit of code that runs, and it's absolutely tiny. And it takes in the value, and it basically lobs it into Azure table storage. And that's basically my data capture piece. I'm going to use these, I'm going to make a table, which is basically a whole bunch of readings, and each row is defined by mapping a POCO. Took me ages to figure out what POCO, plain old CLR object. I'm making a C# class. It has to have some things in it that the Azure storage tables need to use to find what it is, the row key and the partition key, but I'm basically using the device number, the device ID, and the date and time for those two things, and the rest of it's my air quality data. This is my little bit of JavaScript, JSON coming in. There's the device ID, there's the temperature, humidity, pressure, 10 micron particles, 2.5 micron particles, and a magic number timestamp. And that needs to go on the server. Okay, so here's my class, which actually maps onto this with my JSON property mappings in there. So I've got all the names lining up, and that's going to be my reading and go into my table, okay? And this is the code that does it. And this is all it is. There is no more than this, because all it has to do is it has to basically have a particular name so we can find it. It has to have a table where we're going to put the numbers. It has to have a trigger. This is the topic I'm listening to. This is my connection string to the IoT hub. Let's keep going. It's all there. There you go. This is the message that's come in. And this is a log, which I can lob things into so I can see what's going on. So I get my reading, pull out all the bytes, slap it into a string, make myself a new instance of my data storage class, and then just go boop, and it goes into the table. And so this is 4 lines of code which take in an incoming message and put it in a database. And then we return a code that just basically does all the finishing. That gets pushed into the table by this bit, and then boom, we're done. And that's it. And there's this wonderful program called Storage Explorer, which you can also run, which lets you look at incoming messages. And that's kind of, that's just my table. I can then do what I like on the analysis side. I can pull this stuff out. I'm pointing at the screen, which helps you not at all, but I'm going to keep moving. You can get the program from there. This is all free stuff. This is my top hat, which I will now, here's my top hat. Here we go. This is my top hat. And it has a sensor in, there's the sensor. And it has a battery, which is Windows Phone powered, you see. That's kind of like an in-joke. And if you turn it on, it's got some NeoPixels around there. It'll settle down after a while, once it's found the network. Please find the network. It's thinking now. There you go, it's found the network. And with a bit of luck, it's now actually online measuring the air quality. And it'll sit there twinkling happily to itself. You can put it on your head like that, what with it being a hat and all. And you can try and do the rest of the talk while it goes around. If it turns red, then I'll jump up and run out of the room. Now, I've calibrated this to actually light up quite strong colors for no particular reason. Yeah, I'll leave that on. I quite like the effect. So what we've got is a system which is doing what I said. There's the sensor, there's the receiver, and there's the battery. You're seeing it running on top of my head. I'll just go and let's see if we can actually, what I will do is I'll actually unplug here and I'll plug it into my computer. You can't see this bit, but take it from me. I'm now wiring it into my computer. So what will happen now is we can actually talk to it via Visual Studio. So I'm going to stop share. I'm going to change to a different sharing thing. How on earth do I do that? So we go, new share. Right, so if I go to Visual Studio Code, sorry, Visual Studio, the proper one, full fat, here we go. If I go into you and then go share, so now I can basically close that down, just make sure I'm on the same port. I am, and then I can have a chat with the device. Here it is, it's booting up, and it basically wakes up and says, here we go, it's the first run, I'm finding the Wi-Fi, I'm linking up to your home Wi-Fi, Rob, and now I'm actually doing stuff. The MQTT is firing up. This is my sensor saying hello. And it's and there's no GPS and there's no BME on this guy. So now it's publishing a message. So what I do now, because I know I go up to my thing here. This is my this is my monitoring thing. If I do load more, if I then try and do this, I should see towards the end of it. Where's the query thing? Let's go and look for just the air quality top hat readings. You should see somewhere towards the bottom.
That might be in a different window that you might need to share.
Am I? Oh dear, that's silly. Thank you for telling me. Gosh, yes, I assume new share. Let's show you the one you want to see. This guy here. Sorry about that. I'm glad one of you was polite enough to tell me that because it would have been awful. Yeah, so now you can see my incoming packets, and there should be some for today. And at the very, very bottom of here should be the ones that I want to hear to see. And if it's not going to sort on you, try again. I'm not very good at this bit, but somewhere in here is 2020. I'm going to speed on if you don't. Hey, there's some there. There we go. And there we go. This is the ones this afternoon, and there should be some this evening as well. But I'm getting readings in from my top hat, which is super wonderful. And I'll just put him out of the way to prove that worked. Okay, so it can be done. You can use top hats. I'll go back to the slide deck, which is this guy. Please. Wrong one. We can do that. Oh, so yeah, so you have seen that work. If you want to see it going, then I've got there's a screencast on YouTube, which I'll put a link up to, which has a slightly sort of less whizzy presentation, because I'm moving at speed here. I want everyone to get home in time for their tea. But what I hope I've shown you is that this stuff is easy to do and quite cheap, and definitely fun. And you can now use Python. I've got all the stuff I'm showing you there to do with capturing data and pushing it onto Azure. You can do that in Python now. There's some very nice code that will do that for you. So don't just think, I don't know C, can't do this. Use MicroPython. It works there too. Now, I want to do a thing about LoRa, Now, LoRa is worth knowing about as well if you're in the embedded IoT space. It's low-powered radio with a long range, and that's kind of where we come in. It's designed for battery-powered devices where you have battery life measured in years. You want a thing which actually you can put in a car park, and it'll tell you if the car park slot is free or in use for 5 or 6 years. These things are cheap to get hold of. Use a thing called spread spectrum technology, and they're basically an SMS message rather than a phone call. They're a tiny message which is put at irregular intervals, otherwise you flatten your battery, and there are limits on how much you can say and how often you can say it, but that's fine because you're not really using it to stream video. You're using it to send status changes and information. Up to 15, 20 kilometers you can get. We've got some devices on the Humber Bridge towers, and they cover quite a good area, surprisingly. If you've got line of sight, you're nice and high up, you can get quite a good range. No need for licenses, different bands for around the world. Don't do what Robert did, which is buy a bunch of 433 megahertz devices, which you can't really use in this country because it's the wrong frequency, but we'll move on from there. You can use it peer-to-peer. You can buy 2 Heltec devices and you can send messages a few hundred yards, quarter of a mile, whatever. This is a broadcast message, like a baseband network, so anyone can see those. So you may want to put encryption or whatever and do that kind of stuff. You can use it just as point-to-point if you want, but people don't tend to do that. They use LoRaWAN. And LoRaWAN is a wide area networking system which you can use, which lets you actually send messages quite a long way. And you have an endpoint gateway architecture, of which more in a minute. And if you're making a cow tracker, this is kind of what you would do. So here we go. Let's track some cows. Okay. So each cow is given his own LoRa device, which is basically a GPS or some location tracking thing and a LoRa transmitter. And every few hours, the thing says, "Hi, I'm in top field," or whatever it is that you used to say where cows are. And this talks to a LoRa gateway. This is the box you have to buy that has a LoRa receiver and a network connection. And that thing can talk GPRS or Wi-Fi or even wired. And so they ping their messages. That then gets pushed into a LoRa server, which is holding the back end for the LoRaWAN. And that effectively aggregates the messages and then passes them on to whatever you want to have in your back end. So this thing can appear as an MQTT message if you use some systems, or it's just an event saying, "I've heard from this cow, he's in top field." And you can add lots and lots of gateways to make a mesh. And we have this cow here. They all look mysteriously similar because they're all the same piece of, I've only got one cow picture in my collection, which I think is probably a good thing. And so he's being received by 2 gateways. The server is then going, okay, aggregating that. So the back end will get a packet that says that cow message received by these 2 gateways with these signal strengths. So you can do a little bit of detective work to figure out where the thing is based on those RSSI values if you like, but it's not a guaranteed given thing to do. But fundamentally, that's how LoRa works. And this gateway device, the cheapest proper LoRa gateway is about 120 quid and runs on a Pi. And you place these things around your farm, 2 or 3, and they probably, in the case of a farm, you may well put a mobile phone chip in there as well and push them over GPRS, or you could use Wi-Fi, or you could run wires. Any of those things will work, but you put these things out there and then away you go. At this point, I mentioned a thing called the Things Network. Now, the Things Network is what underpins a big network of open LoRa gateways. And so you don't have to make your own backend. You can register a presence on the Thing Network and then run your own application on that to push your cow tracking stuff around, because the way it works is that you effectively, your cow tracker is one LoRa application and your nodes on there are actually cow tracker application nodes. And you can do all this on the Things Network for free. And it's kind of like a European stroke worldwide thing. And if your cow went on holiday to Holland, which happens a lot apparently, mind you, it might be a one-way trip for the cow, but we'll digress on that one. And so the idea is that it will still track it, which will be kind of nice. As far as we're concerned, we have got some LoRa gateways around Hull. We've got some on the Humber Bridge towers now, which is nice. I've got some in Cottingham, which is where we live. And we're getting more and more of these things installed to try and get complete coverage of the city. The way it works is that once you have your gateways, anyone's network traffic can go on there. So if you have an idea in Hull for a LoRa-based app, you can just create it and use it, and the packets get moved around for you. You have your own network ID, you have your own application ID, and they all get pushed around in the name of that network, and it all just works, which is nice. The server sitting at the back, there's actually, you put your gateways onto the Things network, which then hosts connections to them, and then away you go. It's a good starting point, but if you wanted to sell it as a service to somebody else, you probably buy space on somebody else's infrastructure and use that and get your SLAs and whatnot to get good performance and behavior and all that kind of good stuff there. LoRa itself is quite secure in the application context because everything is actually encrypted, and each app has an encryption key, and you can bake these into devices or deploy them via LoRa. So you can use things with a reasonable degree of confidence that they're not going to get eavesdropped and data is not going to get stolen. We don't have default passwords. You have an activation process where you actually onboard the sensors, which can be done by putting a different key in every device if you've got 3 or 4 of them to do, or over the air using a root key if you want to do a whole bunch of these. But basically there are deployment strategies you can use to get stuff out there in large numbers if that's what you want to do. The data itself comes in as a payload of, in this case, a whole bunch of bytes, which I have a little process that runs on the server, converts those bytes into these numbers by running a little tiny bit of JSON-like script to unpick things, because the name of the game is you want to send as smaller amounts of data as possible, and I'm only sending 1, 2, 3, 4, 5 bytes here. I'm getting Celsius, humidity, millibars, 10 and 4 micron particles, 10 and 2.5 micron particles in there. And so this is kind of how it comes down. And your application gets pushed this piece of JSON, which it can then do what it likes with. That's kind of how it works. And this is what a message from the gateway looks like. And here you can see the information about which gateways received it, what channel it was on, how strong the signal was. That's the gateway latitude and longitude. So you can do things to kind of figure out where in the world the tag was when the message was received, which is kind of useful as well. And there are these things called integrations, which are kind of sweet. You can push things into a data store. You can push things to if this, then that. You can push things into keying, which is a nice instrumentation piece, which you can use. You can also use get and post. So I could have an Azure function that's fired when I get my message by a post to that address, which then pulls information out and pushes it into my table. That will work as well. Data storage, we've been using this for a while. That gives you 7 days of storage. There's a RESTful interface using a thing called Swagger, which is awesome, by the way. Swagger's really nice to actually get things back and do things with them. Yeah, really, the Swagger's wonderful. And then you usually get things back and then you can play with them to do whatever you like. So in terms of how you get messages into your cow, should you wish to do that, the LoRa devices don't listen all the time for incoming radio because that would basically kill the battery in a very small amount of time. So you have Class A says, after I've spoken, I'll listen for a few seconds and then I'll go to sleep. And so you can send something back to your device when you hear from it. You go down to Class C, which is basically listening all the time. That needs a powered device. And that's kind of, you might bring things in for a firmware update and do that over a Class C connection. You plug it into the mains when you did that. It's worth exploring. And there is actually a formal link to IoT. There is the MQTT bindings you can find on GitHub. But you can also use timed, I've also used timed Azure functions to bring down batches of data using Swagger from servers as well. There's all kinds of fun you can have with this. If you want to have a go at any of this at all, then it's all on GitHub. I've got code and 3D printable files for the cases. That's my address, which is a little bit out of date now. The stuff, the proper stuff is now running on a community site, of which more in a second or two. In fact, there it is. We are in Hull as connectedhumber.org. We're on Mattermost as mattermost.connectedhumber.org. By all means, go, and we used to meet up in the days when people could meet up without dying. We used to meet up twice a month. Now we do it all on Teams. But if you go to Mattermost or that website, you can see what we're at. In terms of our data, this is a sensor map from yesterday, I think. These are our sensors around Hull. They're grouped together, and then let's see if I can show you some live data. Why not? New share. Let's go find my browser. Where is it? It looks like a browser. It must be here somewhere. Oh, someone's in my browser. Oh, well, there you go. But anyway, show me more file. Come on, let's see more. Show me my browser, please. I've been doing so well with this Zoom thing. My first time out was it. There you go. Boop. So I was looking at Twitter because I'm very vain. Let's see if I can find the sensor stuff. There it is. So what you can do is you can do that. You can zoom in to the map and you can find one of our sensors. This is one of the guys we stuck on a lamppost last year, this chap here. And if I do that, at the moment, the air quality is pretty good. Remember my numbers, 40 is bad. If I look for 3 months, then I can see a pattern of times in the month when things were a bit icky. And you can see there is a trend downwards since COVID kicked in. But the thing I like most about this is if I actually close this one down and I go to another sensor in the middle of town, which is down here, on our map, this chap here, another one of our sensors, and I do the same thing, then I see a pattern of peaks and troughs that broadly follows the one which came from the other sensor. It's not quite exactly the same because they're different sensors in different places, but the big stuff, I don't know what happened in the beginning of there, but it was quite a big one. And there are peaks and troughs here. We saw some quite impressive peaks on bonfire night, surprisingly. But what we're trying to do, we can't actually convince ourselves that our sensors are accurate, but that doesn't really, for me, that's not what we're talking about here. We're talking about making sure that we can get some qualitative idea of these things. We're not getting absolute values. We're detecting if things are getting better or worse or staying the same. And it seems to be working at that level. So in summary, and I think I'm running about on time, but nobody there now. It's easy to build this stuff. You should build this stuff. MQTT is a good way to move things around. An IoT hub is free, easy to use, and industrial strength. The Azure functions combine to messages they send, and you can put these in Azure table storage when you've got them, should you wish to do that. If you want to go out there and count cows, LoRa is a low-powered radio thing that it's probably worth taking a look at. And that's pretty much, I think, there we go. Oh, spider eggs. We need spider eggs. Everyone wants spider eggs. How can your system be broken by spider eggs? Well, my friend Robin had a system, and he'd been very clever. He put 2 devices next to each other on his garden fence, and he was tracking them. And I've given the ending away in the heading because one of his sensors was rubbish and one of his sensors was awesome. And yeah, when he went and looked into this, he found out that this is the point where he found out some spiders had laid eggs in his pipe and blocked it. Took the spider eggs out and away we go. That was the thing we didn't know. Sheffield have a big air quality initiative doing this kind of thing at the moment. They're very busy. They didn't put filters on their pipes, and they discovered that insects like to live in nice, warm, cozy, dry environments like your sensor. And so they'll go in there and make all kinds of whoopee. One of the things that amazes me is the ones we stuck on lampposts in April last year, the ones you've just seen, are still going, which I'm really quite taken with. But that's pretty much, I think, where I stopped. So I'll stop sharing and I'll go back to that, which is, my goodness, gosh, you look old, Rob. Anyway, I'm digressing. But that's about where I stopped. I'll hand off back to somebody else and say thank you very much for being a patient. And I'll not check how many readers I've still got left. Okay, thank you.